All right, here is a great problem that shows the uses of the first derivative test. Okay, we're going to find the intervals of increase and decrease for this function, as well as all extrema from 0 to 2 pi. So, step 1, figure out our critical points for this function on the interval from 0 to 2 pi. And to do that, we've got to take the derivative. So, derivative means I got to use chain rule. All right, I bring the 2 out in front because this is really sine of x, the whole thing squared. So 2 times sine of x, now the derivative of the inside is cosine, plus the derivative of the second part here, which is cosine. And to find the critical values, I need to know when this is undefined or equal to 0. And I'm pretty sure it is never undefined, but it will be equal to 0 from time to time. So I've got to solve this equation. To do that, I can notice that they both have a cosine. So I'll factor out a cosine. This will be 2 sine of x plus 1. So I want to know when cosine of x is equal to 0, and I want to know when sine of x is equal to negative 1/2. And again, I'm only on the interval from 0 to 2 pi, and that is not including 0 and 2 pi. Notice it's an open interval there. So cosine is going to be 0 at x equals pi over 2 and 3 pi over 2. Sine of x is going to be negative 1/2 at x equals 7 pi over 6 and 11 pi over 6. So unfortunately, we've got quite a few critical values here. And so we're going to have to make this table fairly large to fit everything that we need to. So our first row is going to be our interval. Okay, I'm going to leave a little space there. Next is going to be a test value. Next is going to be the sine of f prime of x. Next is going to be our conclusion. All right, and then this one's great because there's no points that are undefined. So we know that all of our changes from increasing to decreasing are going to represent some maximum or minimum. So the first interval is 0 to pi over 2. Now you might ask, well, Mr. Stencil, why isn't it negative infinity to pi over 2? And the answer is because we start at 0. All right, that's our interval. So we're starting at 0 to pi over 2, which is our first. All right, our next biggest one is, I think, 3 pi over 2. No, I'm sorry, 7 pi over 6. So pi over 2 to 7 pi over 6. Then we have 7 pi over 6 to 3 pi over 2. And then 3 pi over 2 to 11 pi over 6. Running out of room here. And finally, 11 pi over 6 to 2 pi. Whew. This is when you know you're having fun. Okay, so a test value. Pi over 2, you can figure out what that is, but I know that a test value in between 0 and pi over 2 would be pi over 3. So I could test pi over 3. Something between pi over 2 and 7 pi over 6 would be pi. Something between 7 pi over 6 and 3 pi over 2 would be 5 pi over 4. Between 3 pi over 2 and 11 pi over 6 would be 7 pi over 4. And 11 pi over 6 and 2 pi. Well, there's no nice ones that we know off the unit circle for this, but I'll just say 11.5 pi over 6 would be a good test value. Okay, so what I want you to do is I want you to plug all these values into your derivative and see if it gives you a positive number or a negative number. I'm going to do the same. Let's reconvene in about 10 seconds. Okay, I hope you had as much fun as I did figuring out whether those are positive or negative. A nice, quick, and easy way to do it, and I don't know if you'll be able to see this, but I type my derivative into that, and so it's in my y1. And then if I get out of there, and you go to vars function y1, you can put in anything you want. Like the first one was y1 of pi over 3. Okay, and I don't need to know exactly what it is. I just need to know if it's positive or negative, and so it's positive. And so just hitting second enter and then going grabbing that and changing it a little bit saves you a little bit of time. So if you want to do that, feel free. But I've got positive, negative, positive, negative, positive. Whew. All right, it's not always going to be like that. It's not always going to switch signs. Okay, you could get positive, positive, negative, negative, positive. All right, so you do have to check every interval. There are some places where it may not change, but it's still a critical value. So that's important. So we know here that we're increasing, then decreasing, then increasing, then decreasing, then increasing. So drawing a little picture, I can say boom, 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 boom. So I know where my minimums and maximums are going to be on these intervals. Okay. So if I want to finish off my problem, I have to first list my intervals of increase. Looks like it is 0 to pi over 2, 7 pi over 6 to 3 pi over 2, and 11 pi over 6 to 2 pi. And then decreasing on those other intervals. Pi over 2 to 7 pi over 6, and 3 pi over 2 to 11 pi over 6. Nice. Now we know when it increases and when it decreases. And so the other part of the question asked to find the extrema. So to find the extrema, I'm going to first list maximums and then minimums. Okay, so I know I have a maximum at, if you can see this still, at pi over 2 and at 3 pi over 2, and those are my only two maximums. So I know I have one at pi over 2 comma something and 3 pi over 2 comma something. I'll have to figure out what those are. And then I also have minimums at 7 pi over 6 comma something and 11 pi over 6 comma something. All right, so I'm going to have to figure out what those are by plugging them into my original function. So I'm going to take a quick break and plug them into the original function, and I'll see you back in 10 seconds.